All right, so in this video, I'm going to be talking through pages 14 and 15 in the notes packet. This is where we're going to start utilizing the time value money calculator the time money value application on your calculator. So in recent days, we've been using this formula to find the values of compounding interest. And luckily, we have a tool that makes this significantly easier. So I don't expect many of you will be using this formula very often because it's often just more convenient to use this application. I wanted to show you the formula first so you guys could get the intuition for how compounding interest works. But now, feel free to just use this instead. So I think it's easiest to just demonstrate how this works. We're going to do that with example 1. So we have Mr. Ninto puts $2,000 in a savings account. It earns 5% interest compounded monthly. How much will the savings account be worth in 3 years? And so I'm going to pull up the finance application, and I'm going to do the TVM solver. It stands for time value money solver. And we're going to be given this list of parameters that's also located here. And what you do is you basically plug in all of the parameters that you know, and then you hit alpha enter on the one that you're trying to solve, and it solves for the value that you don't have based on all the information that you do have. So it's really cool. So let's go through the parameters one by one. So the first one you'll see is n, and we have to be careful here because this is a different n than what is in the formula. So in the formula, n was years, but when you're using this, n is compounding periods. So that's the whole exponent. That's k times n in the formula is what we're just putting for n here. So for example, if you have 2 years, or let's say that we have 3 years compounding compounding monthly, in 3 years, there are 12 months in each year, meaning there are 36 total months. We put n as 36. So it's compounding periods, not years. I is straightforward. I is just the interest rate, right? In this case, 5. Present value. That's the present value from the formula, but a little quirk of this app is that we always want to put it in as negative. The reason for that is because this is built around accounting, and in accounting, if you were making an investment or if you're putting money into an account or you're buying bonds or anything with interest, we're thinking about you are kind of spending that money like it's an outflow, right? It's a cash outflow to whatever investment you're putting it in that's earning money. So it's a negative value now. The future value will be positive. So you're investing money now, that's a negative for your current cash. And then you withdraw it later at a higher value, that's a positive present value. You'll also see this PMT. Set that to 0 for now. That means payment. We'll deal with that next week. So just in the next unit. And then PY and CY, you want to always be the same thing. And you want that to be the compounding periods per year. So down here you can see I do 12 because we're compounding monthly. And the PY is also 12 just to match that. Again, we'll deal with PY and PMT next week, so don't worry about those for now. But let's actually pull up this calculator and run this. So we have $2,000, 3 years, monthly, and 5% interest. So if we go to our calculator, get all these ads out of the way, we're going to go apps, finance, TVM solver. Remember our n, that's our number of periods compounding. So 3 years times 12 months each year means 36 total compounding periods. 5% interest rate. We're putting in 2,000, so we want to put negative 2,000. Payment at 0. The future value is what we're trying to find, so we'll leave that for now. And then we want to change PY and CY to the same thing. We want them to be 12. See, if you put in PY, it'll adjust CY automatically, but just make sure they're aligned. And then we're trying to find future values. This is where the magic happens. We can hit alpha, enter. You can see that in 3 years, that account will be worth $322.94. All right, so that's kind of how this works. Now let's try some practice problems over here. So we're looking at question 1. Lucy invests £7,000. That's the British currency, I believe, at 6% interest compounded annually. find the value of this investment after 5 years. So let's go over here. What is our N here? Okay, let's go back into here. Our N in this case would be the number of compounding periods. So we have 5 years, and in each year we only have one compounding period. So here our N is 5. Our interest rate, we saw that that would be 6%. 6%, a present value of negative 7,000. This will go quicker. Why don't I just pull this up on... Yeah, rather than flipping back and forth, I'll just pull up the practice over here if I need to confirm. Okay. Yep, so 7,000 compounded annually. So we want to go and change our PY from 1 to 12 because it's not compounded monthly. We can recalculate our present value. See that's 9,367 dollars and 58 cents. All right. Now let's look at number 2. What will an investment of 3,000 quid at 4.8% interest compounded monthly amount to after 3 years? So now we're back to monthly, so we're going to change PY and CY to be 12. Our N is now 36 because it's 3 years compounded monthly, so 3 times 12. Interest rate is 4.8. Present value is negative 3,000. No payment, and we're trying to find the future value, and we see it comes out to be 3,463.66 cents. So 3,463.66 cents. All right. So now we have, I think that might be the sign. It's not the yen. I'm not sure what currency that is invested for 4 years at 2.8% interest compounded quarterly. What will it be at the end of the 4 years? All right, so if we go back here, now we're doing quarterly, so we have 4 years and it's quarterly, so N should be 4 times 4 is 16 with an interest rate of 2.8, a present value of negative 2,000. Future value is what we're trying to find. And now we want it to be quarterly, so we're going to change this to a 4. Then if we do alpha enter, we get 2,236.15 cents. 2,236.15 cents. So how much interest has been earned? Well, that's the future value, right? Interest we can find by doing the future value minus the present value. And that would be 236.15 cents, right? We initially put in 2,000. It's now at this, so we've earned the difference in interest. All right, Kelly needs 25,000 for a down deposit on a boat. If Kelly invests 20,000 at 4.2%, compounds monthly, how many years will it take Kelly to earn the down deposit? All right, so let's take a look over here. So we're compounding monthly, so we want to start by changing this to 12. Our interest rate is 4.2%. Our present value is negative 20,000. And we're trying to find a future value of 25,000. Right? Trying to figure out when the future value will be 25,000. And the really cool thing about this tool is that now we can go alpha enter, and it's going to say n is equal to to make sure I have all that in there, right? Yep. So where you see that n is 63.86, and what that means is it's going to be 63.86 compounding periods. until the amount reaches 25,000. So now we just want to convert that to years. So we're going to go 63.866. That's compounding periods, which in this case is months, because we're compounding every month, divided by 12. It's going to be 5.3 years. Right, so it's like 65 months, or a little over 5 years. All right, and then Kaisa puts 12,000 into the bank, compounded quarterly. If Kaisa's investment has earned 14,500 to 2 years, Kaisa's investment has amounted to, I want to change the wording there, has amounted to 14,500 in 2 years. What was the rate that Kaisa's money was invested at? All right. So now we're compounding quarterly, present value. So compounded quarterly, so we change that to 4. The future value, where we're seeing how it gets to 14,500. It starts at 12,000, so we put negative 12,000 there. We know it's going to accumulate at an interest, or no, we're trying to figure out what the interest rate is. We know that it's accumulated over 2 years. So that would be 2 times quarterly would be 8 total periods. And now we want to alpha enter, and we can see that the interest rate would be 9.57%.